G'day everybody and welcome back to the channel. Okay, so it's a bit hard for me to fit everything on the screen for this video, but basically what we're looking at, I've got two of these transformers that I've ordered. I'll go into more details in a minute. I'll just go over what I've got here. So this is going off to the 34401A so I can clip on and we can look at voltages. These are going to the load bank to load down the 12 volt rails with this bridge rectifier and this cap, 2200 mic cap. This big rectifier that's on a heatsink and this 10,000 mic cap will be to load one of the main rails down. And then the load bank here, there's a whole 2 kilowatt of dissipation there. I've got 4 ohms configured here, 2000 watt worth of dissipation. Nowhere near what's coming out of here, so don't worry about the resistors. Alright, these are 500 watt resistors. So I've also got on the active wire the clamp meter, so we can look at the current, quiescent current, inrush current, whatever. So now what I've got to do is I'm going to just make this up, make this up. So I've got these couple of bits of wire here. And we'll start testing. Basically what I want to do is see how much current I can get out the 12 volt rail without the voltage dropping too much. And obviously I want to load down the main rail. At the moment, I've done maths on this. I reckon say with about 10 volts drop around that region with a really strong load on it, it's probably going to be after rectification about 45 volts. Going into a 4 ohm load, that's going to be like 550, 600 watts, something like that. Probably about 550, I'm not sure. This thing was advertised as 1800 watts, that's peak, so it should be 900 watt continuous. Comparing it in size to my 750 watt transformers, it sort of looks closer to one of those. Either way, I'm really happy with it because these things cost hundreds of dollars and I was able to find these cheap ones for a really good price. So if it's a few hundred watts shy of what it was advertised as, for the price, it's more than good. And better more, as I've explained earlier, and you can find this in Bob Cordell's work and Douglas Self's work and Rod Elliott's work, they'll talk about, well, I can't remember specifically which one of them, but I know one of them or multiples talk about custom design transformers, and it's true. I like to run the core a little bit more saturated at idle myself as well, especially for amplifiers, power supplies, stuff like that. So the good thing about this is a 220 volt transformer, so it should run a little bit harder. I ordered this as 40 volt outputs, 12 volt outputs. They're probably going to be higher for two reasons. When we measure the AC voltage, it's unloaded. B, it's going to have 240, not 220 going in it. So we'll just have to see what we get. Let's have a look at the 12 volt rail first. My apologies. So the 12 volt rail's got 14 volts AC on it unloaded. I'm working with a very tight space here, so just excuse me. Let's see what the 40 volt windings come out at. 45.5 volts unloaded. Alright, let's have a look at the standing current. Can't measure it with the clamp meter. Well, not the standing current anyway. That's alright. It's definitely on AC. Yes, it's on AC. Alright. Never mind about that for now. I can always hook up a meter in series with it if we really want to know. I'm not too concerned about that, especially if I can't even see, a milliamp coming up. That thing picks up about 4, 5, 6 milliamps it starts to display, so it's pretty low, the quiescent draw, I'd say. Alright. Now I'm going to get this all hooked up to this. All I've done so far is solder a power cable onto it and put some tape around it so I don't get zapped. I'm going to solder this up to the rectifiers and capacitors, and we'll start off loading the 12 volt rail on this, see what we get, and then we'll move over to the big load bank and load the big rail down and see what we get out of that. Should be fun. Also, for the big rail test, I'm going to leave this running for quite some time, so I'll pause the video and I'll come back. These guys will be warm. I want to see how hot this gets, because I've got heating elements and other things I can use as resistive loads that I can add in parallel to this too. So I'll basically start around the 500 watt ballpark, let it run for half an hour, see how hot it is, and then I'll just add stuff onto it. So the video will be a few little sections put together, but that's the plan. So without further ado, let's get into it. Also, something else I wanted to point out. This isn't really a definitive test per se, because, well, the current that's going to be going through this bridge rectifier is going to be in the order of, 5 to 8 amps, something like that, and they're 35 amp rectifiers. If I can even get the bloody drawer to come out, I'll show you. But normally I buy these 35 amp rectifiers from J-Car. No brand, nothing on them. I'm not saying there's anything wrong with them. They handle the current, they are genuine. However, I recently filled up 3 drawers of these for 90 cents a piece on one of my bomb orders, bill of material orders, if for those of you that don't know. These are actually genuine MIC, not like some of the counterfeit diodes I've gotten off AliExpress before. And I measured the capacitance of the diodes die inside it, the forward voltage, breakdown, all that sort of stuff. And these measured pretty well exactly the same as these, except the capacitance was like half a picofarad bigger than these. So these seem to be a higher quality rectifier. So I'm very impressed with that. However, that's also what's mounted on that heatsink there. So unless, those measurements, unless it's a fake diode and it's got really, really small diodes in it and it can't even handle like 5 amps, this isn't going to be a definitive test. But I still thought that I'd mount one of those MIC brand ones on the heatsink so we can at least start using one and see. I should be able to tell by how hot it gets, how quick and stuff like that too. I know how these guys react. This is not the best heatsink, so I'll be able to tell, I reckon, even at 5 to 7 amps, how that's doing. The volt drop across it too, I can measure, and I'll be able to tell if it's a genuine part or not. So, alright, I'm going to get to wiring. Alright, so I've got both the rectifiers hooked up, caps hooked up, big ones are sitting up here. At the moment I've got the load bank hooked up to this. Let's power it up. What the hell was that? Oh no. Oh no. I can't believe that. I mean, it only happened for a couple of seconds, but that was probably pretty damaging for this capacitor. I just hooked the capacitor up backwards and powered it up with a lot of current. 1 sec. Alright, now I've got to admit, I don't know what happened to that cap. I heard boiling. Yes, it is a very large capacitor. It is brand new. It's possible that, barely anything happened and it's just going to reform as soon as I power it back up. I just hope I didn't damage it a bit. I'll have to do further testing later. Anyway, I've hooked the multimeter 34401 up to this cap, so when I turn it on we can see how quick the voltage comes up and if it does anything funny. Might help if we look on DC. Fair enough. I'll tell you one thing already that I'm noticing that's immediately a problem. I deliberately ordered a transformer with 40 volt rails in hopes that after rectification I would have 54 volt rails, not 63 volt rails. But because this has got a 220 volt winding, I've basically got the same thing. So now I've got 4 honking transformers to build 4 honking amplifiers out of. God. Alright, well, I'm going to set a load on this. Channel 2. At the moment, rectified, there is 18.5 volts. I'm just going to put a 2 amp load on. 2 amps already dropped down to 12.67, so let me adjust that current. That winding is not very stout. Now I only need, like an amp at the most. I think it was like 600 milliamps. Even at 1 amp, it's 14.8 volts with the load off. 18, 15, 16, 18. That's still a bit of a drop. I don't want to fry the winding. Let me set 600 milliamps. Put 700 milliamps. That drops about 2 volts. Yeah, it'll be sufficient. And there is a center tapped setup going on here, so I could halfway rectify it. You know what I'm saying? Get double the current out the whole winding. So yeah, okay. Fan winding's got enough power for my fan circuitry. Yay. That was the one thing that was also important. Alright, well, we don't need that now. I understand you guys probably couldn't see that screen, but that wasn't the important test, was it? This is the important test. So, take big honkin' cap here. I'll just leave that over there. And I'm going to hook up my 500 watt load. I said that was probably going to drop to about 45 volts. That was a pretty darn good guess. You've got to give me credit there. So now, I want to see how these windings warm up. And the rectifier. But I'm not really suspicious of the rectifier. I'm suspicious of this transformer. And from what my hand's telling me, this is getting fairly hot already. But you know what? Interestingly enough, it doesn't actually feel like it's the outer winding. It sort of feels like it's possibly the primary winding underneath that's heating up and coming through. I don't know, it's hard to say. That is getting quite hot. Wow. That's not good. That's only 500 watts continuous, or probably closer to 600 watts. Can't even feel any heat off the resistors at all. Wow, no, I can't leave this on. Jesus. Just quickly, I'm going to have to turn that off. It's getting way too hot. Not a good transformer. It's only pulling 3.46 amp. Jeez. Alright, I'm going to have to relieve it of its load. Let me think about this. I'll set up an 8 ohm load. Jeez, these connectors are really hot. Like really hot. That's not good. These ones aren't, but wow. These leads came with a cheap power supply. Bloody hell. Wow, that's red hot. I can't touch that. I'll take all these out so you can see the meter. So that dropped from 60 watt 2 to 50. That's already a 12 volt drop, which, I mean, you wouldn't even want to see a 12 volt drop. That's, might be alright, but I mean, it still seems like quite a hefty load on a transformer for it to be dropping 12 volts. 6 volts, 8 volts, 10 even, 12. This might be a bit of a problem. So I can already tell now, and like, don't get me wrong, I do get the transformers can get quite hot, but lucky for me, this is going into an amplifier, so as long as it can produce the power, it'll be alright, because amplifiers don't need continuous power. Thank God. I mean, when you crank them up, they start taking more continuous power, but it's a lot easier on a transformer than just hooking a straight DC load. I'm not gonna lie, that's heating up. It's where it is now. This is like basically the most I would want to load it up. This really isn't good. I mean, it's not going to spoil my project because I've got those two really nice transformers. It just means that these will have to get used for a smaller amplifier. Smaller in wattage anyway. It's really stupid because they've used a good sized core and they've just wound it too thin. Like, why? There's no way you could get 900. If you tried to pull 900 watts out of this, you'd burn your house down. In fact, if you tried to pull 600 watts out of it, you'd burn your house down. I'm going to leave it where it is now. It doesn't seem to be getting, stupidly hot now. And I'll come back in a minute and I'll report on it. Let's see how this is going. This is actually getting warm now. I'll put it like that so the heatsink can actually dissipate heat. To be honest with you, that rectifier is actually getting quite hot. I might have to, we'll do it on this video because I don't want to make too many videos just going over power supplies. I've already done videos on the other transformers and snubbers and all sorts of stuff like that. I'll let this run for a bit. Let's have a look at the forward voltage drop across one of the diode junctions. Bearing in mind this thing's only loaded at about 300 watts. What am I doing? I find that hard to believe. Something doesn't make sense here. What? There's no way there's only a 50 millivolt drop. What? I must be measuring this wrong. A 100 millivolt drop. 89 millivolt drop. Let me think about this for a second now. A diode between each thing. Two facing that way. Two facing that way. So I should be reading the volt drop on the diode like this. So that doesn't inspire faith. I don't understand that volt drop. It just seems way too low. And also, why is most of them 60 millivolts, 50, 66, 90? One of those junctions must be running hotter than the rest. I don't know so much about that rectifier now. And that is getting quite hot. Ouch. So are those resistors. Because I've only got 2 of them on. Let me do some math. The amount of heat that's coming out of those, maybe I've miscalculated something and I'm actually running a 500 watt load now. But that's 8 ohms. I'm going to have to get the volts amps watts calculator up. It won't be too long. No, my guess was correct. That's 312 watts. It's pretty well what that feels like. Yeah. So 312 watts. That's coming out half the transformer, don't forget. So actually, and this could still get hotter. So I wasn't thinking straight because I've only loaded half the transformer, and so I should be loading it with 8 ohms. So, I mean, it's happily continuously doing 315 watts. It could do more than that. I'd say at least 350 for each side. So what's that add up to? 700 watts. You know what? I'm impressed. I'm happy. That settles it. That was a good deal. Like I said, I mean, if you go online to buy these in this sort of size and power, you're looking between $300 and $900. I got 2 of these for $300 delivered. The shipping was more than the transformers, let me tell you that, because of the weight of them. The transformers were only like $50-$60 each. This was a ridiculous score. Ridiculous. So there you go. That's quite happy to do at least 350 watt for each half winding. With a push-pull amp. That'll be happily putting out at least 700 watts. And when you take into consideration that it's not so continuous on an amplifier, this would actually probably work in a 900 watt RMS amp. I'm not going to lie. Would I do it? No, I like to oversize things, but I've seen 500 VA transformers in 500 watt amplifiers, measured the output, and they had 500 watts available into 4 ohms. You know, they do handle being overloaded a bit, and like I said, in an audio amplifier, because it's not so continuous, you can get away with it, especially if you oversize the cat bank. But should you do it? No. But like I said, I'm happy. I can squeeze this thing tight and hold my hand on it, and I'm right on top of the secondary, and it is just warm with 312 watts on it, on half of it. So yeah, I'm going to call that 750 watt, not 900, 750. But like I said, you'll have to go back and look at the video. I showed the listing for this in the video. They're like $45 or $55 or $65, somewhere in that ballpark. So I mean, for a 750 VA transformer that can do that sort of voltage, you know, I really can't complain. I am more than happy. I'll tell you what, we'll take a quick current measurement. Oh yeah, this meter can't handle that much current, can it? What can this guy do? You know what? I'll just get the good old Fluke. So that was, in case you can't see, 6.2 amps. So this all works out because, I mean, I think I needed about 7 or 8 amps in my amp. This is obviously capable of producing that. So that's good. And I guess the other advantage of it is that under load, it will be probably around that 45 to 50 volt mark, or maybe 47 to 52 volts when music's playing, which is good because the transistors won't have to dissipate as much power on themselves. So yeah, for the price of the transformer, like I said, about $50, I am more than happy. That is a 750 VA transformer. I mean, like, even if you run this on a hot day and it's in a little box, I can imagine it getting a little bit hotter. So I mean, 650, 700 still. For $50, you still can't complain. I think that's a good deal. So I'm impressed. That basically concludes the video. All I wanted to do was load this down, see what I could get out of it. Is it enough to build, say, a 500 watt amp? Yes, it is. Wonderful. Wanted to have a look at this rectifier. I'm going to have to do a deeper dive into this. It's probably something I'm just not thinking about. But I do want to load this down. I'm going to have to... I've got power supplies other than these power supplies. When I say power supplies, I mean I've got a huge welding transformer that's about this big that I rewound myself. That thing can dump out 350 amps at like 12, 14 volts, maybe even more. I've got a switching power supply that I've modified that also does, I think, even more, at least 300 amps at 14.8 volt. So I can definitely get 35 amps through this. What I'll do is I'll get one of those low voltage power supplies, hook it up to one side of this, and I'll load it down with this. Actually, this can only do 20 amps. And I'm sure that's not on one channel because I bought the dual option. So whilst it's a 400 watt load bank, it's only two 200 watt channels. I didn't buy the single 400 watt version because I would prefer. Let's just see what the current goes up to. Yeah, no higher than. Oh, really? Okay. This thing can't be dual 400 watts. I'm sure it's 200 watts aside, but maybe it can do 20 amps. Interesting. That's alright. Look, I've got resistors, like I said, heating elements. I've got all sorts of stuff in here, so I'll conjure something up. Low voltage, high current power supply, and some sort of resistive load probably. And I'll test one of these 35 amp rectifiers and I'll compare them to one of my known good 35 amp rectifiers. Not saying that they're good quality. I got them from JCar. They're some no-brand Chinese rectifier, but I've been buying them from there for years. Used them, loaded them plenty of times, had no problems with them. So I know that they are at least a 35 amp part. So at least we've got something to compare this against. Alright, so I did a bit more thinking about this. And I'm going to say 750 no, because in a case on a warm day it's going to be a bit hotter, and although it's push-pull, each rail still needs to provide the full current, so it is a bit undersized. I'm going to say 600 VA, but still for the $45-50 that it was for a 600 watt transformer, you really can't complain. What I'll do when I build my amp is, because I'm interested to see, I think this is going to have more volt drop than those. I think whatever transformer I fit, I'll be able to get the rated power out the amp. This is just going to drop more voltage and get a bit hotter. But I reckon that would probably cause more THD because there's going to be more fluctuation in the rails that the feedback and input stage and the whole amp has to try and deal with. Output transistors, everything, right? So it's probably going to be better with a more stout transformer. But we'll still have a look and see how it goes. It might surprise us and these might turn out to be better than what I thought they were. We'll see. If not, and they're not the best match for a 1000 watt amp, I've got plenty more amps to build coming up. We can build 600 watt amps with 300 watt channels, for example. Something like that. Smaller amps, Oh, I mean, wait, what am I saying? Maybe like 150 watt channels, 4 of them. Or 200 watt channels, 4 of them. Maybe both. I don't know. We'll have to see. I feel like I might be undershooting that a little bit. They probably can do more than what I think. Like I said, audio is not as continuous as the way I was loading it. Plus, the way I was measuring it isn't the most accurate way of doing it because I've got the volt drop on the wiring, the diode bridge, all that sort of stuff. If I measured it loaded and measured the AC coming out of here and measured the current and did the math on that, that would be the most accurate way of working out what it's continuously providing. But yeah, they're at least a 600 VA transformer. Just wanted to point that out. Other thing I wanted to let you guys know is I ordered 2 of these, and this one arrived damaged with a nick in 3 of the windings. I contacted the seller and showed them the picture, and they're sending me another transformer, no questions asked. That is a very easy repair. So guess what? I got 3 for the price of 2. Can't complain there. Anyway, I'm going to end the video here. Like I said, I think they're closer to about 6, maybe 650 watt, but for the price, I'm still very, very happy. All right, thanks for watching, and I'll see you all soon. Take care.